What's poppin', dogs? Mr. Allen here with a couple circle problems, and I drew these a little bit too large, so I'm in the circle here for the math, but that's all right. Nice big diagrams. We got some chords, some radii. Let's see what happens here, all right? The circumference of circle G is 34 pi meters. FD, where's that at? FD is 16 meters. Find GH, which is this guy here, AH, which is just this guy here, and IE, which is this little segment over here. Okay, so we got three things to figure out here. Let's analyze the situation. We currently have radii drawn that are perpendicular to these chords. Well, that means that those radii bisect the chords. Now, I've already used these marks here, so I'm going to mark this and this. All right, so these two are congruent. These two are also congruent, but before I mark them, okay, these two chords are equidistant to the center, which means that the two chords AC and FD, Jenny's barking at some dogs next door. So AC and FD are then congruent as well. So then these pieces here and here are going to be congruent. So we got four segments already congruent. A lot of that stuff happens in these circle problems where we have congruent chords or chords that are equidistant to the center, perpendicular, bisecting. All this stuff works out so nice. That's why I love circles so much. All right. So FD equals 16. This whole thing is 16, which means these pieces here are going to be 8 meters. Let me get a different marker here. They're going to be 8 meters a pop. Okay. Let's see here. That looks terrible. That's a little better. Okay. So 8, 8, 8, and 8. I'll save the units for the end here. It's all meters. We'll put that back in at the end so it doesn't get too jumbled up. All right. So we know that the circumference is 34 pi. What can I get from the circumference being 34 pi? Well, if I take my circumference formula, which is 2 times pi times my radius, and I set it equal to 34 pi, I can solve for r. Divide by 2 pi on both sides here. The pi's cancel. 2's are gone. Right? R equals 34 divided by 2. That's 17 meters. Boom. Okay, so that's my radius, which is GB and GE. But that's not really going to help me with a whole lot. What if I draw in a triangle somewhere? You can actually draw it in 4 different spots here. I'll pick this one. Seems like it'll be the least amount, like on top of my face and such. All right, so let's go here. Boom. Okay, and this is going to be 17 meters. Cool. So now I have 8. I've got 17. I have a right angle, right? So this is a right triangle. I can solve this with some Pythag. Or better yet, 8, 15, 17 is a Pythagorean triple, okay? Now, if you didn't know that, if you didn't remember your Pythagorean triple, you could have 8 squared plus, then we'd have b squared equals 17 squared. You'd solve for that one. We'd end up with... what is that going to be? What, 225? Something like that, right? Let's see here. 17 squared minus 8 squared. Yeah, 225. So you'd have b squared equals 225. We'd square root it, and you'd get 15 for b anyways. Okay, so there we go. Wonderful. Fantastic. What do I do with this information? Do I have anything that I need yet, right? Sometimes you get so lost in finding out a triangle, and you're like, wait, what am I answering again? We want GH, that's this guy, right? Oh, wait, hold up. GI is congruent to GH, so I know that GH is, let's put that down here, GH equals 15, right? Meters. Awesome. I got one. AH, I already labeled that as 8. Okay, awesome. AH equals 8 meters. And then IE, which is this guy right here. Hold on. Our radius is 17. GE is a radius. Couldn't I do 17 minus 15 equals 2? And now I have, I don't know if this is going to fall off the screen here. Maybe. I think we're okay. IE equals 2 meters. Did we fit it? I think we did. Okay. If not, I'll write it right here. IE equals 2. All right. So there we go. We got all 3 parts of this one. Again, it's all about setting up triangles within a circle here for these problems, which is kind of neat, right? I like bringing in the triangles. I like bringing in the Pythag. It's a cool thing. Sorry, all this is on my face right now. All right, let's go over to this one here. So we have in circle G, we got AC and DF are congruent. AC and DF are congruent, okay? B and E B and E are midpoints. Let's just mark that right now. If they're midpoints, all of these guys are going to be congruent, right? If AC is congruent to DF, then these little guys are all going to be congruent. All four of them are going to be congruent, right? Because the bigger segments are congruent, and I split them in half, so their halves must be congruent. Okay. And then we have AC and DF. Okay, sorry, AC and DF respectively. AB is 12. Okay. So this is 12 inches. Oops, there goes my ruler. And GE is 5 inches. Okay. We want to find the area and the circumference of circle G. Well, to find the area and the circumference of circle G, I need my radius. So my goal here is let's find our radius, right? Now, our chords are congruent, right? AC and DF. Remember over here, our chords were equidistant to the center. Thus, they became congruent. And it actually works flipped around. If my chords are congruent, then they are equidistant to the center, which means this guy is 5 inches as well. And now we can draw in, let me get my ruler real quick. We can draw in a radius, right? We can draw in a radius on this thing. And I'll just work with where I have my 5 and my 12 already written down over here. So let's see if we can line that up. Boom. We've got, what is that now? 5, 12, 13. That's a Pythagorean triple as well. 5, 12, 13. We did 8, 15, 17, 5, 12, 13. These guys are coming in super handy. If you didn't remember your Pythagorean triples, it's okay. I got you. 5 squared plus 12 squared equals C squared. That's going to be 169 equals C squared, square root. And we get C equals 13 inches. Okay? So if you remember them, awesome. It saves a little time. If not, you always have Pythag in your back pocket, ready to rock and roll. So now I have my radius. We can get our areas our area and circumference. So area of the circle is equal to pi times 13 squared, which I know is 169 because I just took the square root of it, right? So we get 169 pi inches squared for area. And if I wanted the approximation, the decimal approximation, I can just type that into my calculator. 169 times pi gives me 530.929, so 0.93 inches squared. If I'm going to the nearest hundredth, 2 decimal places, right? And then circumference, that's going to be 2 times pi times my radius of 13. So I'll get 26 pi inches squared. And if I wanted to type that in, we got ourselves 81.681. So 81.68 inches squared. Usually we stick with the in terms of pi when it comes to circles. It just keeps it a little bit neater, you know, in your mathing, right? We don't usually multiply it out. Now, if I was using this for some kind of an application purpose when I'm finding the area or circumference of a circle, if I was building something and I wanted to know, you know, the square footage, I'm not going to go to the store and be like, yes, I need a 169 pi inches squared of stain from this part. No, I'm not going to do that, right? So you're going to get the decimal equivalent for that. But in math class, we usually keep it as 169 pi or 26 pi, not inches squared. Oh my gosh. What am I thinking? My goodness. That could have been bad. That could have been bad if I left it there, man. All right. So there we go. Area, circumference, whole lot going on. These things are intimidating at first, but once you start breaking them down, you kind of see a similar thing happen each time. We looked at set up a triangle and then, keep on mathing from there. And look for those Pythagorean triples. They are going to come up quite a bit because they're just nice numbers to work with in this kind of more complex situation here. All right. That's about it for this one. Have a wonderful day, and thanks for watching, guys.